Hi, I want to talk about how we can calculate the change in entropy of various thermodynamic processes that aren't the adiabat. Because an adiabat has no heat, so if there's no heat, there's no change in entropy. Well, we'll start by looking at an isobar, because in reality we really only need to look at the isobar. Our change in entropy would be our change in heat divided by the temperature at which we're exchanging that heat. So if we look at the first law of thermodynamics, a small change in internal energy, dE, would be equal to a small amount of heat added to our gas plus a small amount of work done on our gas. So our small amount of heat, dQ, would be equal to our small amount of internal energy, dE, minus the small amount of work, dW, that we do on the gas. So I would take each of those terms and divide by T. So for my change in internal energy, the internal energy of a system is the number of moles times the constant volume heat capacity times the temperature of the system. So that would give us the number of moles times the constant volume heat capacity times dT over T. For the work done on a gas, it's minus the pressure times our change in volume, so that would give us a term of plus our pressure divided by temperature times a small change in volume dV. And that's a pretty easy integral to evaluate. It just gives us the natural log of T. But volume and temperature aren't necessarily independent of each other, nor is pressure independent of them. But we can use the ideal gas law to simplify our lives a lot. From the ideal gas law, our pressure is the number of moles times the universal gas constant R times the temperature divided by the volume. So if I multiply that by my change in volume over my temperature, the temperature cancels out and I get a similarly easy integral. I would have the number of moles times the universal gas constant R times the change in volume over volume. So to find my total change in entropy from my initial state to my final state, when I integrate the right-hand side, I get the integral from my initial temperature to my final temperature of dT over T, and the integral from the initial volume to the final volume of dV over V. So for an isobar, and really just any general process, the change in entropy would be equal to the number of moles times the constant volume heat capacity times the natural log of the final temperature over the initial temperature plus the number of moles times the universal gas constant times the natural log of the final volume divided by the initial volume. Now, if you have an isotherm, for an isotherm, T final equals T initial. That first term drops out and we just get the second term as the change in entropy for an isotherm. For an isocore, we have a constant volume. So our second term would end up dropping out. So for an isocore, it would just be the number of moles times the constant volume heat capacity times the natural log of the final temperature over the initial temperature. Thanks for watching.